Starting with the key concepts used, the first one is Coulomb's law, which is used to calculate the electric force on a charge and is K times the charge of the point and of the external divided by the distance squared. The second is the electric field equation, which is K times the charge divided by the radius squared. Newton's third law is also used in calculating the charge by setting the equal and opposite forces of gravity and electricity equal. Finally, the gravitational force equation is used in the form of mass times gravity. The purpose is to illustrate the distribution of excess charge, how electric fields interact with each other, and to test the differences in point versus line charge models. The assumptions used throughout the experiment are that there is no air resistance, the tape is treated as a point charge, so all of the charge is at the center of the tape, and that the U-tape has the same amount of charge and is evenly distributed. The final results are that the positively charged tapes repel each other. The charge was 1.353 e to the negative 8 coulombs, and the loss of electrons was 8.46 e to the 10 electrons. The errors are that there are potentially unequal charges on tape A and tape B, and charge may have been lost with handling. The system was the pieces of tape with everything else being the surroundings. The initial conditions were 3 pieces of neutral tape, 2 being of equal length and the third being placed down onto a desk. The experiment details were: a piece of tape was placed, then tape B was stuck to and ripped off of that piece of tape. This tape was then put near different objects to determine its charge and was then placed near tape A, which had the same charging process done to it, until some of tape B floated. This distance was measured and used to calculate the charge. The length of one of the pieces of tape was 0.2 meters, with the mass being 0.0002 kilograms. The distance between was 0.029 meters after an average of 5 trials, and the magnitude of the gravitational force was gotten with mass times gravity and gave 0.00196 newtons. The magnitude of the electric force was F grav equals F electric, since for an object to float in place, that has to be true. So that also gives 0.00196 newtons from mass times gravity. And then the measured electric charge on the floating tape. Once again, we know F grav equals F electric for the tape to float, so mg equals kq squared over d squared, which gives q equals 1.353 e to the negative 8 coulombs. Expectations and observations. I expect the tapes to repel each other since they will have the same charge if they both repel my hand. The 2 tapes do indeed repel each other and both attract a neutral object. If the U-tape is positively charged, how should it interact with a charged plastic pen? Since the plastic pen is negatively charged, it will attract the positively charged tape, and then since it's negatively charged, it will repel the negatively charged tape. A neutral tape will attract the pen, and the sign of the charge of the top tape is positive as it attracts the pen, and the bottom is negative as it repels the pen. Since the momentum of B is not changing, you know that the net Y component is 0 on tape B. And then next, tape A exerts an electric force up and the earth exerts a negative force down, which is shown in the free body diagram. And then in order to determine the gravitational force on B, the quantity needed to be measured is mass, which was gotten in the setup values to be 0.0002 kilograms. The similarities and differences. The model predictions between the point charge and the line charge gave 2 different values for the charge of the tape, which is expected as the line charge is closer to the actual experiment setup. The data and model from the second coding section gave the same value for the charge, while the point charge was close but a little off. Calculate the number of atoms on the sticky surface of your tape. The atom area is 1 e to the negative 20 meters squared, and the tape area is 4 e to the negative 3 meters squared. So tape area divided by atoms area is 4e17 atoms. And then computing the ratio of the number of electrons to the number of atoms. The electrons on the tape was 8.45 e to the 10, and the ratio is electrons over atoms, which gives 2.11 e to the negative 7. The code gives an output of 1.353 e to the negative 8 coulombs for the charge, which is close to the charge calculated in the beginning. I included an excerpt from the code containing my experiment 0, which takes in what tape it is, the R magnitude, and R hat values to give the electric field for that tape. I then calculated the electric force shown directly below that. The code gives the magnitude of the electric force and the gravitational force, which I set equal to each other to get the charge of 1.353 e to the negative 8 coulombs, which is what I got in my experiment setup. I adjusted the Y value in the top tape code with the average distance between them from the experiment, which was 0.029. I then adjusted the scalars until the model made sense. Closing questions. For what if? There would be no change since it is just a physics convention and would not affect real-world outcomes, meaning that opposite charges would still attract and like charges would repel. For the Y section, I got that they are different because the second treats the full length of the tape as having charge, but in the first part, the charge is being treated as a single point. This means that the more accurate one would be the second one, as it is actually a line of charges in real life. For the conclusion, the tapes became positively charged after being ripped off from the tape on the desk, which caused them to repel each other. When the positively charged tapes were brought near a negatively charged or neutral charged object, the tape and object were attracted to each other. This shows proof for the concept that like charges repel and opposite charges attract. The charge was 1.353 e to the negative 8 coulombs, and the loss of electrons was 8.46 e to the 10 electrons.